Hello, welcome to ENSC 2800. As part of our concurrently taught online classes, we're going to be recording lectures and tutorials on the exercise on the topics that are covered, how to complete the exercises, and introducing us a little bit to our modules here in this class. Right now, we're looking at Blackboard in my recorded screen. You can see I have course information. I have important links and videos, such as the USDA Food Desert Atlas, the USDA percentage of fast foods, and other pertinent links. As this class progresses, we may be adding individual elements here so it'll look slightly different. Today, I'm going to cover unit number 1. If I were to click on unit number 1, our objectives in unit 1 are food as a geographic fact, geographies of food, agro-systems, and an introduction to mapping. The people who teach this class are going to be teaching this class with a focus on the spatial relationships to food and food access. What I'm hoping to do is that with each of these units, we're going to do a short research presentation on things that NCCU faculty and students have done in the past. So for now, I'm going to record my presentation. I'll record our short research presentation, and then we're going to look briefly at exercise number 1 and how to complete it. Chapter number 1 talks about food geographies, social, political, and ecological connections. In our classes, geography is the study of where phenomena are located. We can see high values near other high values, low values near other low values. And so in this particular class, we're really going to be focusing on the geographical component. It could be weather, food access, food availability, where are SNAP locations, median household income, all those facets of geography that impact supply chains, availability, purchasing patterns, where you can buy food, food deserts, and other things that we've done in our research before. So our learning objectives are to recognize the multiple meanings of food and its very complex geographies, and we're going to look at examples of these in our practical application as part of the exercise as well. We're going to appreciate its significance to social and environmental health and the urgency of better understanding the relationships between food, environment, society, and ultimately health outcomes. Conceptualize food as a geographic fact that connects people and places, and become familiar with the interdisciplinary breadth of the growing field of food studies, of which NCCU faculty are a major part. We start to think about food in terms of interdependent social, economic, political, biological, and health systems that have impacts on all of these, and get introduced to the key theoretical concepts, tools, and methods used by geographers, the people who study where, to make sense of how people produce and consume food within geographic information systems, so that we can map these applications and then facilitate data-driven decision making. So food is a lot more than sustenance. Beyond eating, many engage with food as a cultural phenomena. And we post food on our social media. We watch food TV shows. We visit specialty markets. And often food tells a story of who we are and often where we come from physically and culturally. Historically, food has been a major source of struggle. Populations have disappeared because of insufficient food or inadequate food, and many wars have been waged over agricultural resources such as land, water, climate. And these days we have something called climate refugees, people who leave areas because the climate is not suitable for sustainable agriculture. Worldwide, we have almost 1 billion people that are undernourished and do not have enough food to live a healthy lifestyle. This is typically what we call the global south. Previous generations, we used the term third world countries. In the United States, about 50 million people suffer from food insecurity. And we'll talk about what food insecurity is, and we're going to look at an example from our research presentation that also addresses that as well. So food security or insecurity is the measure of availability of food and of individuals' ability to access it. And we'll talk about that more in our research presentation, because when we talk about this access component, there's a physical access, but there's an economic or monetary access to it as well. According to the UN Committee on World Food Security is defined as meaning that all people at all times have the physical, social, and economic access to sufficient, safe, and nutritious food that meets their food preferences and dietary needs for an active and healthy life. And I really want to focus on this economic access because we see a lot of healthy food out there, but in some cases, or a lot of cases, people aren't able to economically or purchase these things. Even though we see healthy food, it comes at a price. We see fast food, it comes at a price. It's easy. But what are the overwhelming health outcomes attached to these? So when we think critically, should food be a commodity that's bought and sold? Is food a right? Do people have a right to food? Should people profit off of food while others are food insecure? And should basic food necessities be free? We're starting to see a day and age where schools offer free lunches. Schools offer free lunches where children are able to have a right to food in these particular cases. So when we talk about food geography, food has come under increased scrutiny as we begin to realize the social and environmental costs generated by our modern food systems. And that was really brought to the forefront in 2008 when the First Lady talked about childhood obesity, child health, and really making sure and ensuring that our younger generations have access to safe and, more importantly, healthy food. There's been books and documentaries that have described the problems with the way we produce and consume food and propose solutions. And they reflect and fuel the social anxieties regarding the safety, health, environmental sustainability of food. Because food needs to be produced somewhere, and geographers, we believe that that somewhere matters. The physical geography of place, such as climate, natural resources, soil, water, accessibility, shape food production, availability, taste, and diet. And within our program, we have environmental science. Environmental science is the study of how people essentially degrade or improve the natural systems such as air, water, and soil, which are necessary for the growing of food. We also look at the human geography of place, economic, political, social, and cultural characteristics related to consumption, spending patterns. And we have access to tons and tons of data out there that looks at this access, who spends on what types of food locations are located in particular places. And so when we talk about food as a geographic fact, is that there is a relationship between food, people, and the environment that is dynamic and mutually constitutive. In the global context where population continues to grow, economies are increasingly connected, and there's increasing environmental pressures to keep these spatial relationships so that all regions benefit. Because if you have to pay a lot of money for food to go to your location, well, that costs is going to be passed down to the consumers. So food is intensely geographic. In particular places, we've organized ourselves economically and politically to provide for the most basic human needs and support populations at various scales, from rural communities to the global economy. Here we'll be looking at a lot, in the first couple exercises, we'll be looking at our local food environment in North Carolina. And it's our connections to the earth and the biophysical environment. So it relies on natural resources like soil and water, but more importantly, good soil, healthy water, healthy air, but leaves a drastic mark on the environment and severely alters landscapes, causing ecological climatic changes which are experienced and addressed differently across place and space, and also how we respond to these. And it's powerful why we identify ourselves culturally and relate to each other socially, and it's a cultural symbol of practice, and food is a power agent in placemaking. It has the ability to distinguish, exclude, and bring people together and reveal much about individual cultures. And so there's been a lot of scholarly work on food as social fact. And this means we understand food is shaped by our social environment, economic circumstances, moral values, social norms, political and fashion that vary across space and time. These food systems are a systematic perspective that pay attention to the connections between production, distribution, marketing, regulation, consumption, tied in with our natural environment, and how economic, political, environmental, and social comes together through food. We have an example of a food system map where we have food, and as you can imagine, these are all the biological, economic, health, social, and political systems that are at work to make all these things to put healthy food on your table. We have some key theoretical challenges that we try to study our frameworks within these concepts, such as space, place, network, scale, and then nature-society interaction. Some of these facets or these theoretical concepts include colonialism impact on global food trade. Where is food security insecurity most prevalent? And we're going to look at some research papers that do that, done by NCCU faculty and staff. How does climate change impact food yields, and what is the environmental food footprint of food? And then what factors impact or influence food access within cities? So some of the things we're going to look at is impact of biotech on indigenous communities or low-income communities, impact of farm workers in rural places, food festivals, how do they transform cities, and then where do you live that increase or decrease your health. What are the impacts on communities as well? So when we look at geographic methods, we focus on field work, which is the process of collecting data, people, and cultures in the natural environment. And in this class, I plan to have us collect some data in the field using our little phone, and so we can collect information about our food environment, or maybe in particular your own personal food environment, using both quantitative data and qualitative data. Me personally, I like working with quantitative data because it's quantitative. We can run statistics on these, but also qualitative data that describes qualities, descriptions that can't be quantified within numbers, drop downs, things like that. We can also debate the validity of qualitative versus quantitative data and look at the validities of each of these. Because when we look at the geographic methods, this class is largely going to focus on mapping and spatial analysis. Mapping we use to look at the spatial location, typically 2D representation of the Earth where data are displayed. And then we look at critical geography concerned with the power and inequality in both real-world spatial arrangements and their representations. And then GIS, which is a large focus of me personally, which is Geographic Information Systems. And then spatial analysis, finding meaning in spatial data. What are all the things that we can do to spatial data? And in this class, we're going to focus on these. And then content analysis. And so I thought this was kind of interesting. This is a map of kind of iconic foods in the United States. I lived in Idaho to do my graduate school, and as you can imagine, Idaho was famous for potatoes. I lived in Maryland for a few years. Maryland, blue crab. North Carolina, green fried tomatoes. New Jersey, sloppy joes or key lime pie or whatever. And we thought that was relatively interesting related to this. Now, the other thing we're going to do today is we're going to look at some of the practical applications of food security analysis. And this was a presentation that I gave with a student a few years ago on how to compare travel time calculations versus Euclidean distances as applied to the study of GIS. So how do we quantitatively measure these? And so we're going to talk about applications of food access, food availability, and the exercise that we've provided. So in the United States, we have obesity, and we can map obesity. Obesity is spatially related. You can see it's kind of interesting. The dark values are near the other dark values, the lighter values are near the other lighter values, which I think is inherently interesting. And that's what a geographer studies. Geographers study where phenomena are located. You don't see the reds and the yellows and the greens and the whites all kind of sprinkled in between each other. So we find that really interesting is that there is spatial relationships related to obesity, even though to me and you, we think of that as kind of individual or random phenomena that are going to be unique to each and every person. And we can see an article from 2020 that talks about the US obesity rate tops 42%, which is highest. We can talk about all of the reasons why. And we looked a little bit on the impact of health, impact of health, including COVID-19 risks. But when we look at the pillars of food security that we described previously, we have food availability, we have food access, food utilization, and food stability. So food availability basically means, is there healthy food around you, yes or no? If you kind of just walk out your door or drive down the street, what type of food out there? Is there a fresh market or is there fast food? Now there's lots of ways to measure these. We can measure these using density, proximity, or variety. Density meaning within your zip code, how many fast food locations per 1,000 people? How many supermarkets per 1,000 people? We can look at proximity. What is the nearest fast food to your home versus the nearest healthy food location to your home? And that's actually what we call the food balance ratio. Or variety. What is the ratio of healthy food to unhealthy food? However, we classify healthy food and unhealthy food. And that's what we call Retail Food Environment Index. And then we have something called the Modified Retail Food Environment Index. And we've got some presentations, papers out there that look at that. Now, food availability, it's purely geographic. Food access, meaning, do you have access to transportation and do you have the ability to buy it? So food might be half a mile away, but if you need an Uber, you need to get on public transportation, you don't want to walk that half a mile, well, that's really going to be pain to get that food back and forth if you don't have individualized transportation as well as the economic access to pay for that Uber or get onto that public transportation and go and do that. So access brings in to an availability and a transportation component that combine the two as well. The other thing we look at is food utilization. These are typically can't be grouped at the block group or zip code level. These are things that are grouped at the individual level. So if I had a farmer's market or a fresh market or a supermarket right next door to me, am I still going to drive 10 minutes to the fast food location? And so we can look at spending patterns on fast food, healthy food, fruits and vegetables, tons of different things. We have access to lots of different databases because we want an end goal to be food stability. We've used the term food deserts before. Food deserts are kind of being phased out for other terms here, but these are the food deserts in the state of North Carolina. There's lots of ways to measure food deserts, but they are typically defined as low income and low access, and in this case, 1 mile within an urban area, 10 miles in rural areas. So you can see in eastern North Carolina, we have a lot of these large census tracts, and census tracts are subdivisions of counties. And so in some counties like Durham County, we have about 50 census tracts. In smaller counties, we might only have 1, 2, 3, 4 census tracts, based on population. But you can see the locations of all of our food deserts in North Carolina. And these are highlighted in pink. Now we can superimpose spending patterns with those food deserts. Now the one thing about mapping is that it starts to get really ugly really quickly when we start to superimpose multiple tiers and layers on top of each other. And so we have different tiers in North Carolina, which is tier 1, which is your economically disadvantaged up to tier 3, which are economically advantaged counties. But I also have our tiers combined with our food deserts combined with spending on fresh vegetables. And so you can see these maps that have spending on fruits and fresh vegetables that are highlighted in blue. And you can see in the Raleigh, Durham, Chapel Hill area, there's higher spending, about $300 to $900 a year on fruits and vegetables, versus these lighter areas, which are $0 to $182 a year. And so what we're looking at here are zip code maps. And these are called choropleth maps, where we color in the individual polygons. So within a GIS, we can represent phenomena using points, lines, and polygons. And we can look at these as well. And we could look at food deserts. And you can see down below, I've got a little bit of spending. The average spending on fruits and vegetables in food deserts is 182 versus 264. So you can see in non-food deserts, spending on fruits and vegetables is a lot higher. Now, these maps look really pretty, but there's a lot of issues with density and variety. When we measure density, we're basically counting the number of food sources within an enumeration unit. An enumeration unit is just a polygon, like a county or a zip code or a census tract. And if you've taken GIS before, you've heard these terms. There are a lot of variety measures, such as the Modified Retail Food Environment or the Retail Food Environment Index, but we run into issues of those because if we work in small, rural, or residential regions that might have just 0, 1, or 2 food sources, your possible values are 0, 50, or 100. So if 1 out of 2 food sources is healthy, it's 50%. If 2 out of 2, it's 100. If 0 out of 2, it's 100. So we have a lot of kind of randomness with those data. Because geographers like me, we hate checkerboard patterns. I don't like looking at checkerboard patterns where we have a red next to a blue next to no data. So some of the options we've started to look at in this study was, I want to measure the proximity between a starting point such as my house and a food location, and I can group all the houses within a particular zip code or block group. And there's different ways to measure these. We can measure Euclidean distance. That's just straight line distance. That's really easy to calculate. We can measure drive distance and drive time. Now we do this all the time with our phone, where we type in an address to the nearest supermarket and it tells us how far it is and how long it takes us to get there. Other ways, and when we talk about that food access component, are walk time and the time to take public transportation. So that whole food access, these are some of the different ways. These days we can wait for a ride share, wait for a family member to come pick us up. And so when we look at these, I'm just looking at a particular location to drive to the nearest supermarket. This is over where I live in Guilford County. And you can see the drive time, drive distance. So the drive time is about 11.92 minutes. The drive distance is 5.69 miles because you're going on largely rural roads. And then you can see the Euclidean distance, which is 4.34 miles. Now this Euclidean distance is really, really easy to calculate. Okay, you all can calculate it because we all took math class where we did the distance formula. The square root of delta x squared plus delta y squared. But you know, in reality, most of us aren't going to hop in our helicopter and fly this straight line distance. And so we're going to worry more about the drive time and less about the drive distance, but even though that does matter as well. Now, what we tried to do was a study to compare, all right, if I measure Euclidean distance, is that just as good as measuring drive time and drive distance within our food desert studies? And this is just the first of some research presentations that we're going to talk about that look at this at the local level. What we did, and what our student did, was look at this for Guilford County over in Greensboro. I live over here in a little town here called Summerfield. But it's got a population of about 500,000, and Greensboro has a population of about 300,000 people. We have rural regions that compose about half the area, but only about a sixth of the population. One of the things we can do is there are different measures of proximity, availability, and access that are grouped within various enumeration units, such as census tracts, block groups, which are smaller, and then we can look at spending patterns here. So in Guilford County in the bottom left, we can look at spending patterns on fruits and vegetables. And you can see in the north and the northwest portion of the county, you can see spending is much, much higher for fruits and vegetables than it is for other parts of the county as well. But also I can map here is I can look at the drive time in minutes to the nearest healthy source. I can do it from the middle, or I can look at all the addresses within a particular tract or zip code and then average them together. So it's like taking your phone and imagine typing in the address for you and your neighbor and the one other person down the street and doing that hundreds of thousands of times. Now within a GIS, we can do that relatively quickly. And we can also group this at different scales. So you can see here in Guilford County, we probably have about 50 or 60 census tracts here up in the upper right. And then each of these tracts is composed of 1, 2, or 3, maybe even 4 block groups. So here we have about 200, 220 block groups here, and you can see them broken down. So our research problem that I talked about before was, how do Euclidean distance calculations compare to drive time? Euclidean distance is really easy to calculate. Drive time's a little bit harder. Like I said before, you want to type in, you want to go to the store, do these calculations. Imagine having to do that 100,000 times. So our average GIS user is really good at doing these Euclidean calculations, but GIS professionals, which I hope you're going to be, are able to do this. And so we've made a couple of maps, and in particular, our student made a couple of maps where we looked up in the top the Euclidean distance versus the drive time, because if I'm going through and doing research, there's a big difference between the two. Euclidean distance is easy to calculate, but it's not practical. Drive time is practical, but not as easy to calculate. And so we have some challenges that we run into between these. And so being able to ask these appropriate questions, I think, is really important. Now, some of the methods we used, we have about almost 300 block groups in Guilford County. We have 118 healthy source locations. Like I said before, we can calculate these from your house, your neighbor's house, but in this particular case, we just calculated these from the block group centroids, literally the middle. X marks the spot in the middle, and we calculated the drive time using what we call the near function to do Euclidean distance, and something called the closest facility, meaning I want to type in Bank of America on my phone, find the nearest Bank of America, and drive me there and tell me how long it's going to take me to get there. And do that while we're at it 292 times to 116 possible healthy food locations, which we've defined as supermarkets in Guilford County, even though they do offer unhealthy food. So Euclidean distance, we had minimum, maximum, standard deviation. If you've taken stats before, you're taking my geostats class, will know exactly what all of those mean. But we have the minimum distance, and then the minimum network drive time, the maximum. So there's a block group out there that takes almost 17 minutes to get to the nearest supermarket. What can we put there? Are there going to be other options there? Are there unhealthy options? This is probably a rural area. Is Dollar General going to come in and fill the void there? And on average, it takes about 4 minutes to drive to the nearest healthy food location or supermarket. Now we have something here called a histogram. So you can see the Euclidean distance in miles. And that's just kind of representative of this first column. And then we can see the histogram for drive time. Each of these you can see, they represent what we call a normal distribution, which I think is really interesting. And then both of these are going to be skewed to the right. You can see this outlier, a couple of outliers right here with the Euclidean distance calculation. And the same thing with the network drive time. So we've got 1, 2, 1, 1, 1 here that are more than 10 minutes. And we can do queries on all these. So we can do some market analysis. Are there enough people located in these areas? The other thing that we can look at is what we call clustering. We can run hot spots and cold spots. Excuse me. So we can run hot spots and cold spots. So this is a hot spot on the Euclidean distance. This is a hot spot on the drive time. Are these different? I can definitely see some areas over here where they're slightly different, where we have hot spots that exist, cold spots over here that don't exist. So you can see some difference. Cold spots meaning they are low distance, but here when we calculate in the drive time, they're not cold spots. In these areas here, these blue areas are quote unquote good, meaning they have low distance. Okay, cold spots are low regions or low values surrounded by other low values, where that high value surrounded by other high values. And then we can see this buffer region here. So these areas in red are high Euclidean distance. These areas in red here are high drive time. We can definitely see differences between these. Now to me, there's a whole lot of values here, but when I open these up, I have the number of cold spots, number of hot spots, number of not significant, and you can definitely see there's a difference between these 292. Especially down in southwestern portion right here, we have a big difference in the number of cold spots here using Euclidean distance versus drive time. We literally have 2 of them here in the southwestern portion here. So we can see there's a definite distinct difference. And what our student also wanted to do was map the z-scores. A z-score is the difference between the value and it's basically calculation of the standard deviation. Brings in how far it is away from the mean based on a z-score, which is unitless. And so we had our students do some Euclidean distance with the z-score. So we can map the z-scores here, and then we can look at the difference in z-scores between the two. So we can look at, hey, this is a big difference in the z-scores, meaning that we should it means that the difference between there's more of a variation between the Euclidean distance and the drive time, meaning, these people are probably going to have to drive a lot further than what their Euclidean distance represents. So our difference in z-score means that the drive time and distance are equally distant from the mean. Meaning, if you've got a high drive time, you probably have a high z-score or high Euclidean distance. So they could be really high or really low. It doesn't matter. So block groups with higher z-scores mean that for distance it might be lower, but the drive time is higher. It could be for a lot of reasons, because what we did was we went and mapped scatter plots here. So you can see here, these areas in the top here, they have a really low distance, but really high drive time, which I thought was kind of interesting. And so we ran something called an R-squared. But when we look at the applications of these, we can look at the differences between these maps to see, for Euclidean distance and drive time, to see how they are manifested in our Food Access Atlas published by the USDA. And so we found that 6 of these block groups coincide between the groups of low income and low access. The one thing about these maps look largely the same, but if you really start looking at these, they're very, very different. And these statistics show so. You can see there's some purples here, but not as many purples here. There's some purples here, but not as many purples up down at the bottom here. And the blues and the reds that highlight both low income, low availability, and then when they're both low income and both low availability, it typically means that those are the food deserts that we're looking at here. But this was a presentation that was given by a former student of ours, and it was supported by a grant used to study food deserts and food access, and we were really happy with that. So I wanted to highlight some of the practical applications of what we're looking at. Now, the one thing that we're going to do with all of these exercises, I want to do a link to the exercise map. So I've done the presentation. Now, the other thing we do is we have a presentation and then we have a practical hands-on application. And in this tutorial, I'm also going to highlight how to open up the maps and how to do all those as well. So if I right mouse click on exercise number 1, I have an exercise right here. I have not done the publish the due date as of the time of this recording, but what you're going to do, it's 10 questions. Each of the exercises are worth 20 points. So you can see at the time of this recording, I don't have a due date, but we will publish it as well. So I have the exercise that you're going to take. I also have a link to the map. So if I right mouse click and I open up the map, you're going to see a map in here that opens up that has, this is what we call a web map as opposed to a web app. Now this map isn't going to magically open up. So if I open it up in another browser right here, I'll show you what it looks like. So when we open up our software for the first time, you're going to see something that looks like this. You're going to need to sign in right here. Okay, you will need to sign in, and I've provided a login for you to sign in. So you cannot do the first exercise until you are able to log in. Okay, so what you're going to do, you're going to click down here at the bottom and click on North Carolina Central University. It might not even have this information, so what you're going to have to type in here is type in DEEGS NCCU. And up it's going to pop North Carolina Central University. And so I'm going to log in using my NCCU credentials. You're going to type in your username at ad.nccu. And then you are going to sign into that. Oh, it looks like I've updated my password. And I'm going to need to sign in using my credentials and then using my login information. That's the way we log into the software. Right? This is the way we log into the software. And so now when you open it up, you're going to see a map here. A map right here. It's got major cities, rivers, counties, zip codes. This is what our desktop software looks like. What we're looking at right here is what we call ArcGIS Online. These are online maps. In the bottom left, we can zoom in, we can zoom out. I can check on things here. I can click on zip codes right here, and you can see this represents median household income. So you can see median household income right here for all the zip codes in North Carolina. In addition, I can X out of all of these here. I can click on Show Table. And so I have all these tables right here because when we look at a GIS, essentially, we're looking at an Excel spreadsheet that's going to be linked to a point, line, or polygon. And so I can zoom into this point right here or zoom into this polygon right here and look at all the information about it. Now I'm waiting a second here for my map to pop up, but I can look at all of this information right here about Rockingham County. I have something called POP 2010. I can see what else I've clicked. Okay, I clicked on a zip code called Reedsville. Clicked on a zip code called Reedsville that has an ID of 2730. It's got a median age of 44, median household income of 43,804. So I can look up the highest and the lowest on these. Okay, I'll show the table for counties right here. So you can see there's 100 counties. I can highlight Alamance County. Look at that. And you can see it's highlighted on the map. Okay. So what I can do with all of these, and I'll X out of this here, I can sort these as well. So for POP 2010, I can sort from lowest to highest, highest to lowest. I can click on these dots. I can calculate fields, hide fields, or whatever. But you can see for each of these are going to be linked to a point, line, and polygon on the map. So if I click on this one right here. This is Charlotte-Mecklenburg County for Pop 2010, had the highest population. I can do these as well. And what I'm going to ask you to do is go through some of these tables, zoom in, zoom out, look at some of these things here, like I just did. And so this is what we call a web map. Eventually what we can do is I can create an app and insert this map into the web app so you can't change the colors. Because if I click on major cities here, watch what I can do. I can edit the style on this. Instead of making it a red, I can make it a blue. And there it is. So I can save this map. So hopefully you're not able, again, you can see me logged in at using my ad.ncccu.edu. And the expectation is that everyone will be able to sign in using your AD address, NCCU username and password, so you don't have to log in using another one, and be able to do this. And so what you'll be doing, and I've kind of moved this over to the side, is that you'll be able to go through and answer all of these questions. We zoom in, we can zoom out. We have questions about attributes, which are the individual columns. We ask questions about the median household income, which zip codes have the highest median household income, in which county are they located, and then it also covers some of the concepts that we talked about in our lectures. So good luck with this exercise. We kind of summarized. Feel free to go back, stop, zoom in, zoom out on these maps. These are really powerful maps. And you are able to log in as well.